Measuring Water Turbidity. I am Alan with phosphorusrecycle.com. Welcome back. In today's presentation I will describe turbidity and its objective measurement. Turbidity is the most common term for the cloudiness or haziness of water caused by particles. Turbidity is an optical property. The most direct measure is reduction in strength of a light source as it passes through a water sample. Its measurement in drinking water is important because the possibility that bacteria can cling to the suspended particles. The chemical characteristics of the particles themselves also interact with disinfectants, making it difficult to neutralize the pathogens. I prefer to start experiments with rainwater because the municipal water districts multi-source water. They include recycled water. It troubles me knowing that people and industries upstream have contributed to my tap water. The water district adds things like fluoride, chlorine, and other chemicals and procedures that change the water in character. There are too many chemical interactions. I think it better for my purposes to start with the most pure material I can gather on my own, which is dripping off my roof. It's easy to filter through a coffee filter. Some of these today are down to 5 microns, and then through an activated charcoal filter. My collection trays sit outside under the roof overhang. We typically get 90% of our rain in only a few days of the year, so a rain event is reasonably predictable. The rainfall from the sky hits the roof, slides down the roof slope to the collection tray. I remove the water after an event and put it into containers for storage. I note the date and the collection station from which the water was drawn. I write that information on the container. Water is a universal solvent that starts collecting contaminants as soon as it leaves the cloud. There is debris on the roof. Birds and mammals use the roof and leave things up there. The big fires up north put a lot of dirt into the sky. A lot of material had collected, which should be in our first batch. The first rain event is where we can expect the greatest turbidity. I think it's interesting to examine the water and its debris through a microscope. I use one with a monitor screen, as several of us can look at the view at the same time. Modern microscopes also allow the researcher to take and save images. I show some pictures from drops collected from my Station A, Event 1. To measure turbidity, one could use a professional scientific nephelometer, but the prices start at about $1,000. For most of my purposes, the inexpensive simple direct voltage reading I show here is sufficient. I show a glass bottle about 1 liter in size that is reasonably square. I position the bottle to get maximum light from the light source. For my setting here, it was the skylight over my work area. I use an inexpensive 1.5 DC solar cell I bought mail order from Home Science Tools. I hooked up the solar cell to a digital voltmeter with a 2-pin screw terminal from our Arduino set. The first reading is a control and is expected to be near the maximum rating of the solar cell because there is nothing in the bottle yet to attenuate the light source. You can see the reading of 1.327 volts. Then I poured a water sample into the square glass container. You see the reading of Station A, Event 1 of 1.156. Empty and repeat with the sample and record the reading from the digital voltmeter. You can see the reading of Station A, Event 3 as 1.204. In a standardized setting, we're getting objective readings that reflect how much light can pass through the fluid. As one would expect, there is a lower DC voltage reading for the cloudier water. That is all we're trying to show. From those readings, we can rank order the sources and dates of containers and turbidity of the water rather than just guessing from the opinion based on one person's visual inspection. Judgments between two people may disagree, but the voltage reading is objective and repeatable as a science procedure should be. Thank you for your time and attention. I am